Everyone to the stream. Are you here? You're here. You're here at the stream. The stream. It starts. It starts right now. You're here. Are you here? If you're here, you're here. Welcome to the start. It's the start of the stream. Welcome, everyone. All right. How's everyone doing? How's everyone doing? Let's get our announcement out. Let's get our announcement out. Let's do a red circle. Twitch.tv/Lenser. That's where we are right now. We are live. We are live doing, also I forgot to put live. Compiler cogen. Today we're doing compiler operators and type checking. Hopefully. Part 13 at notice. Alrighty. Send that announcement out. We are officially live. That reminds me, my phone is not on silent. It's always a great reminder. And Twitch is going to be right up after it with the mobile dashboard warning, I'm sure. They always are. Alrighty, I'll get my phone plugged in so it don't die. Get that juice. Perfect. Landor XD says, I can't watch yet, but I'm claiming my daily streak reward. You've earned it. You've earned it, Landor. We'll welcome you when you get back. Thank you so much. I really appreciate you. So awesome. Landor XD is always here at the start of the streams. It's amazing. We are going to be working on the compiler today. And as we said in the announcement, we are going to be working on, let's see, type checking, but also operators. So I think we should work on operators first because they need type checked. So I don't want to start the type checker before we work on operators. Yeah, that's different. So a node, a valid binary operator. Contains how many children? 3? 1 is going to be, I guess, 2 children. It only needs its 2 because it can contain a symbol which is bound in an environment which will contain the operator information. This will work. This will work. These will work. So a valid binary operator contains 2 children. 1 is going to be the left-hand side, often abbreviated as LHS. And what do you know? The other one's going to be RHS. I think that works out. I think that works out. Sweet. Good enough for me. I think I can pause this and switch to my OBS now. Don't need to be downloading the stream as I upload it. So a valid binary operator. It contains 2 children, the left-hand side and the right-hand side. So the idea is that this is already an operator that has been found here or something. Binary operator. Yep, that's how I do that. Also, that should be functions, but whatever. Okay, so binary operator, each one in the table, we'll just call it what it is, binary operators. Oop, what did I do here? Environment. I cannot spell, but I can code. So sorry, my chair is being extra loud today. Hopefully that's not too bad on the microphony. So we're gonna have a symbol, which, what do you know, is the operator. That's going to be bound to some list of things, which is going to be, we'll just do none for now. And what is that list of things going to be? It's going to be bound to a list for, first of all, integer, with its precedence. It's going to have, I guess, a left-hand side return type. So symbol left-hand side type and a symbol right-hand side type. Oh, and then, but before any of that, there's also going to be a symbol for return type. This is getting a little more complicated as far as things go in the environment, but I think it's going to be fine. I'm just going to line these up like this. I don't think it's the best, but it does work. They should probably also all be on new lines. Whoops, like that. Yes, but that, why? It didn't work. Oh god, I don't know what I just did. Yes, I know. Right around there. That's good enough for me. So with this environment, we are going to store binary operators. We're going to store them with the key of a symbol, which is the operator itself. That way we can find it while we're parsing. And finding this information is necessary because we're going to need the precedence of each operator while we parse, and then this is all necessary while type checking. Alrighty, I think that's a good start. So let's go to parser.c. I think we should define, like, make new binary operator or define binary operator or something like that. We're going to do that. Okay, where should I do this? Probably above parse program and stuff. I guess it doesn't matter if I just put it in here somewhere, right? We'll just make it void. Nah, we'll see error. Define binary operator. We'll do void. We'll see if we can write it without one. So we're going to need a context to define it in, right? And I guess these should only be global in the, or these should only be valid in the global context, or even nested scope definitions should define it in the global context. So you can call a function that defines an operator a new way, for example. Okay, that's not bad, that's not bad. In any case, we can keep it going and say we have our context. And yes. So we have our context. We're going to need a symbol, right? The operator. We're going to need a bunch of types. So we're going to need the return type. We're going to need the left-hand side type and the right-hand side type. Okay. So this will be the binary operator that we are going to store in the environment. I guess something like that. And we would like to make node symbol with operator to our binop. This returns an int, so we should say int status. So yeah, we're probably gonna have to return an error, or at least an int. Okay, so we have a binop, and we would like this to have, oh, it's right here. So we're going to have node add child. So this binop node is this right here. So we're going to add child to the binop. And I would like an integer node. And this is going to be precedence, which we're also going to need. Look at us. This is getting ridiculous. It's a little better. Alrighty. Status equals environment set. And then we're gonna have to decode status. First time chat. Heyo, first time chat from a new viewer. How's it going, Sobripute? Or Sobripute? I don't know how to say that, but he says, hey, evening. Good morning to you. I love time zones. Hopefully I'm not too tired for you this evening. I did just wake up. How are you doing, Sobripute? What brings you into this stream working on a compiler? So we add the child for that. I guess these have to be symbols, don't they? So we can look them up in the type environment better. We should just store them as type IDs, but it's fine. Superpute says it's almost 11 p.m. here. Lamau, yeah, it is. It's almost 8 a.m. here. So you must be in East Asia, because I'm in West America. Or you could be in, like, I guess Russia? It's that far over, right? You'd have to be far up. It'd be cold. Return type. Okay, so I can keep the names. I just have to change the types. But that's incredible. It's really cool to have viewers from all over the world. It's like, it's so, it's just cool, you know? I don't know. I know I'm not that interesting, but it's just crazy to have, like, to be able to collect, like, just send messages from entirely across the world and we can understand each other. It's so cool. In any case, we are working on Sobripute says, I always want to write my compiler, but always stuck at parsing stage. Cry. Cry face. I get it. I get it, man. We spent a long time on parsing. Right? It's not simple. There's a lot to deal with, right? What I recommend is trying to build a simpler parser and then kind of work your way up from there, if that makes sense. Because how I got started parsing is I made a Lisp. If you don't know what Lisp is, it's a really old language, old programming language. And I really love Lisp. But I wrote an entire interpreter, runtime interpreter for Lisp, which requires a parser. But the great thing about Lisp is that the AST that the parser generates is literally the same thing that it intakes. You don't actually build a tree. It's like the parentheses are how the tree works. So you don't have to actually build anything. It's very simple. Soperpute says, I'm from Malaysia. That's amazing. That's really incredible. That we're just like talking. Just some kid in America and some person from Malaysia just like chatting it up. It's pretty cool. I like what Twitch does. How it can bring people together. But yeah, we got stuck on parsing on this compiler for a while too. If you check out the YouTube link, there's like 6 3-hour videos of working on parsing. So that's 18 hours straight that we just worked on parsing. And we kept changing how it worked and what we did, and we're still gonna change it because we're not even gonna support the syntax soon. So lots to do, right? Lots to do. Soberpute says, I know, right? Courtesy of internet. That's right. Big underwater cables connecting the continents. It's crazy life. Crazy life we live in. So if status equals 0, then this is going to be an error. So we're gonna have to error create error. Yeah, I just finished your first video, planning to go through the rest of your videos. Wow, thank you so much, Soberpute. I would really appreciate that. That's amazing. I can't believe it's interesting. I feel so dumb all the time. I'm like, people, okay. I feel like I don't know what I'm talking about, but hopefully. As long as people enjoy it, I guess it doesn't matter to me, right? That's really cool. I'm glad you watched the first video. I can't believe you watched it all. But yeah, we're here. We're doing it. What type of error is this? This would be a failure of binding in an environment. A binary operator. So we're just going to call this a generic error and say could not define binary operator in environment. Return 0. Yeah, good enough for me. Soberbute says, trust me, I watch a lot of that on YouTube. Oh, I missed one. He says, nah, I enjoy watching people write their own compiler. Trust me, I watch a lot of that on YouTube, lol. That's awesome. That's really, I mean, that's pretty sweet. Out of everything you can watch on YouTube, that's a pretty Chad thing to do, right? You ain't just watching cats. You're like, I want to watch people create compilers. Creation of new binding. So equals, what is 2? Existing binding value overwrite ID unused. That's fine. Doesn't change anything for us. So if it's 0, it's an error. Else we can just return OK. Oh, return the error that we created. Soberpute says, well, I just weird, I guess. I don't think you're weird. I think it's like Giga Chad type stuff. You're like expanding your knowledge and pursuing things that you care about, which is so rare these days, right? So it's really cool to see. I don't think you should feel weird. You can feel weird. I give you permission. It's okay to feel weird. But you don't have to. I think it's completely normal. It's just that most people shut down that instinct within them and they go, I'm just going to do this because it's easier or because it works or I saw them do it. And then it's like, well, yeah, you're just like interested in compilers and watching stuff on it. He says, haha. Ho ho. Okie dokie. Can I clean this up a little bit? Not really. Not really cleaner, is it? Yeah, we'll go with that. We'll go with that in the header. It's not my favorite, but it's fine. So now we just need to, also I'm gonna say, whoa, okay, good. I accidentally alt-tabbed out of Emacs by hitting Control-Z. That is what that does. Suspend frame. Interesting. I've never hit that before. Amazing. In any case, we need to probably get the, okay, so we should say while context. We'll do a fix me. Every binary operator definition is global for now. Why not? Context equals context parent. Is that how that works? Yes, it is. So this will get our context while context parent. Yeah. So once we get a context with no parent, aka the very top level context, that will be our global context. And once we've reached that, we can say, heyo, define our environment in that. I think that's pretty concise. If there's an error and we cannot define it, we return an error. I think this is not bad. Node symbol does use std, right? It does use std, so we don't have to worry about ownership. These are all stolen, effectively. Same with the operator string. All right, that's pretty good. I think now we can, when we start parsing, so in the default create, we add the integer type, And we're gonna add some operators, some binary operators now. We also need to set this environment to something, which is one of these. Binary, there we go. Nope, binary, you had it right. So we would like to set in this environment, no, it's an int, isn't it? In status. So this will be, oh, no, it is an error because we now have defined binary operator. Can just pass the context. We can say the operator we would like. We can say the precedence it will have. We'll just give +5 for now. The return type, it's going to return an integer. The left-hand side type, integer. Probably to do is going to be, should we use type IDs versus type symbols? It's something to think about. Hey, Simon. Simon the Swede has showed up. How's it going, Simon? He gives a love sign. I love you too, Simon. How's it going? Thanks for showing up this morning. Or afternoon. Whatever time it is for you. So multiplication has a higher precedence, which means it goes lower in the tree. Multiplication and divide should be equal. We can put these to an enum. Fix me. Use precedence enum. Simon the Swede says 5 p.m. here. Going to take a swim in the ocean soon. So hot here at the moment. It has been so hot here as well. It's been like 100 degrees for weeks. It's terrible. I'm glad you get to swim in the ocean. I forget, if you are in Sweden, isn't the ocean on like, you have a lot of ocean and lakes, from what I remember. There's like, it's kind of like Swiss cheese up there, with all the lakes and stuff. Which I'm jealous of. But up here we just have like dry, I guess down here, we're a little more towards the equator, and it's very dry. We're in a valley, and there's still like barely any water. There's never a flood. It's not good. At least I'm not in the desert, like in Arizona. I think I would literally turn into a cactus. Just like, I was gonna go out in the desert and stand still, look into the sun. Try and activate my mitochondria or whatever. Get more powerful. Simon the Swede says, I live all the way down at the south coast. We got the best beaches here in this country. I would believe you. I would believe you. I've seen people go to Sweden and all they say is, that is the most beautiful country. There's beaches, there's mountains, there's trees. Push QRDX says, try and preserve water by standing in the sun. That's right, standing in the sun and looking into the sun. Okie dokie. So we now have some operators. Would you look at that? We have some operators. Would you look at that? Okay, and this operator... Hi there, Push QRDX. How are you doing? Thank you for coming in, tuning in to the stream today. I very much appreciate your returned presence. This is going well. This is going well. So we are defining binary operators in our environment. We have precedence, type information, and everything. And yeah, we're gonna have to do this. We should really have this whole thing in like a macro, but it's fine. And this will say failed to set built-in binary operator in environment. And look at us, we can just repeat that. And what we can do is say, just to reduce on things, binop error message. And yep. Shouldn't we use puts? And then we don't need a /n. Look at us. I don't want to append. Thank you. That's better. I could probably also do this. Whoops. Nope. Okay, we'll do, yeah, this. And then the idea would be like that. And look at that. That's much better. A little more concise. A little more concise. Yeah, we're making progress. How's everybody doing? We got Soberbute, we got Simon the Swede, we got PushKRDX already. This is a great stream. Thank you everybody so much for tuning in. Landar showed up and claimed his badge, but he said he has to be back later. So we'll wait for him to show up. He's like, hey, by the way, I'm here first. And then he left, which is pretty baller, to be honest. So we add a type. We add binary operators. Why is this called node add type? I don't like that, but it's fine. This should be define type, is what it should be. But it's define type. That's much better. I think that's cleaner. PushQRDX says, you gotta assert your position before going away. That's right. Assert dominance. Take the T-pose, make eye contact, then you can do whatever you want. Mr. Mugame, how's it going? Thank you for tuning back in. He says, I just ordered all parts for the 8-bit breadboard PC. I don't know if this was a good idea. I think it was a great idea. I've done electronics before. I think it's a lot of fun and you learn a lot. I think it's a great idea. Because it's cool to have like the real world in front of you. And it's like, oh, that capacitor is being charged. Cool. It's like, I get it. That's sweet. So now that's charged. And then you can touch it to like a screwdriver and it goes, dah! It zaps. And it's like, ooh, that was fun. Make sure you hold it in pliers in case it explodes. Don't like hold it in your hands and touch it to the screwdriver. If that makes sense. But there's all sorts of things you can do with electronics. It's a lot of fun. You smell burning plastic, you're like, oh, I put the wrong resistor in, didn't I? Whoops, shut the power off. Soberpute says, how did you learn to write all this stuff? I had to pause there, because the only thing I could think of was to say your mom. But your mom did not teach me, in fact. In fact, I'm a self-taught systems programmer. I basically, through sheer willpower, made myself learn. Did you figure it out by yourself or take a look at other people compiler? Okay, let's do a little explorationo into my origins, huh? That's not right. I need a guest window. Okay, so if we go to, sorry, you can't see yet. If we go here, Soberpute goes lol. So this is my GitHub. It's linked down below. And if we take a look, you can see that there's light, which I worked on. I am working on. It's just I like streaming a lot. But this is one of the first like actually well-meaning programs I wrote. Like this is the first program that isn't trash, I would say. And that taught me how to write a compiler through Lisp, because Lisp is very simple. So it's like my style of writing a parser is very much taken from this website. And this is found in the Light repository on my GitHub, so you can check this out. It's all open source. And I just extended upon this Lisp, like his garbage collection it's only for pairs, and I wanted to garbage collect strings and stuff. So I just made the garbage collection work with strings as well, and I just started adding things and did all these different things. Share that link. Sobrepute, it's down below in the GitHub, on the GitHub link down below in my About section on Twitch. I can also just do this. It's in chat for you. And then you can go here and check out the tutorial I followed, and also you can check out this source and all the stuff I did with it, right? If you're interested in a text editor. And then before that, I also wrote an OS. That's kind of how I learned C++, is I wrote an entire OS in like 4 months. And Sobrepute says, all right, thanks. Mr. Mugume recommends the Crafting Interpreters book, is also great. Yeah, it's very good. I think for me, the Crafting Interpreters book is harder to understand. It feels like a steeper learning curve than a Lisp, but I'm sure it's different for everybody. Because in my head, I can picture like a recursive pair structure very easily, but other people may be able to picture different structures in their head very easily. Sobrepute says, yeah, last time I go halfway, maybe need to go and reread that book. That's true. Maybe I know enough now where I can go and reread it as well and learn more. But yeah, I made an OS and this taught me C++ because that's what I wrote the OS in. I wrote an entire kernel, right? So this entire kernel was like me learning C++ for real and how libraries work and linking, and yeah, it was a lot of fun. Sobrepute says, last time I lost at Pratt parsing stage. Hey, that's what we're doing today. We're doing Pratt parsing today, bud. So you're in the right place. But yeah, just check out my GitHub. There's all sorts of projects that you can see I worked on and kind of learned a few, like 6 months ago, how to truthfully write programs. But I've been writing programs for probably 10 to 15 years. And I've played video games since I was 3 years old. So I've been a computer boy, you know what I mean? I've been the nerd for a long time. So it's kind of just a natural progression to learn this stuff, I think, for a truthfully, like, to my core, I'm a nerd. All I do is sit in my room and think about things. I don't like talking to people. I don't like going out. I like talking to you guys, but that's different. We're talking about interesting things. I don't like saying, like, how's the weather today? I'm not into that. Sobrepute says, oh, cool. Yes, we are working on Pratt parsing. We're going to be doing our... the cool part about Pratt parsing is there's no, like... It's kind of just an idea with precedence. It's not really a hard and fast rule. Like, this is how you have to parse it. It's just the idea of using precedence in this manner, which is really cool. PushQRDX asks, how is the weather app working today? Now that's a Chad question. That's a Giga Chad question right there. How is the weather app working today? See, this is like Zoomer small talk. Oh god. Okay, so we can define a bunch of operators. That's all fine and dandy. Now we have to parse them. So, null denotations. Where are null denotations? Here are our null denotations. Okay. PushGirlDX is Lamau. So after every... We should never return OK. I don't think this should happen. Why do we return OK here? We return OK so that we don't... Oh, we never actually reach this? So let's see. Where is this? The reason I don't want to return in here is because I kind of want to add a check for a left denotation down here and not in here, if that makes sense. So yeah, this is within a function definition. So we don't return OK within a function. That's pretty good within function parsing. But we do return OK within variable parsing. Okay, so if it's a variable declaration, is this what this is? Yeah. So we have a variable declaration. And then if there's an equals after it, we continue. Otherwise, we just return okay. But truthfully, we want to end up down here. Is this a while loop? No, that's an else. So we would continue after here. So we would just have to say that it's not an unrecognized token if we get here, which would mean that the else didn't work. Okay, so effectively, I get it now. I get it now. Do we ever, because we continue at the end here, I don't think we ever return okay. We break. So I think what we're actually able to do, and that's just breaking out of this. Yeah, I think what we're actually able to do is get rid of this else and move all this to the left. You want to try it? We're going to try it. Okay, so it's the one below the error prep. We can do that. And then we just, probably just go up like that. So now, if it's a function, we'll go through all that stuff and continue parsing the function body. So the function is now here. We continue. Or we don't continue because we don't take this control flow path, which means we'll end up here and looking for more things. I think that's pretty good. So now we look for a variable, or a type annotation is what that is. So we look for a type annotation after a symbol. And then we look for an initialization. And let's see. I've been streaming over 30 minutes. I do want to mention, if you are enjoying, please hit that follow button on Twitch. We are so close to Twitch affiliate, where we get custom emotes, channel points, all sorts of things for all of us. I really recommend it. Hitting that follow button so we can get to 50 followers and we can have a whole little celebration, right? It'll be fun. So the idea is that whenever we get an expression, we want to end up so after getting a variable declaration with no assignment, all we should do is move on and kind of parse the next thing, right? I don't know if we necessarily need to return here. So if we don't return here, it's going to be unrecognized. But if we don't do this, we're going to try it. Ooh, I didn't even build it today. So we're going to do our build from uncompiler. So this is CMake. We would like to build the debug build and run it and give it our example file. Not bad. What happened? Hooktar. I miswrote. Hey, look, it worked. It worked. I know it works every time. I shouldn't be surprised, but I'm surprised. It worked. Look. It worked. Okay, so now this, let's just make sure this example program with comments everywhere is so unreadable. You can see we have foo, a function call with 2 integers, 20 and 34. This is looking good. 10, 5, 42. 10, 5, 42. Those are all variable reassignments to C. That is what that is. C is, yep. Yes. Variable reassignment to B. Yes. So declarations still happen. Variable declaration B. We are good. So we can just remove this and things are fine. We still have to do that. So this falls through because variable declarations don't necessarily have an expression. It's not necessarily a lefty notation that has a right-hand side. It's just a unary denotation. All right, so the idea is that if we print the node like here, should we get every node that's parsed? What is it, result? Okay, yes, this is making sense. So we get every node that is parsed, but then we still get the, as we're building the function body, each parsed expression becomes a bigger part, like makes the function grow. If that makes sense. Then we get a function call. Then we get a function call with 2. And then we print out the program like normal. So we do get literally every single node that is parsed passes through this moment right here. Perfect. So look ahead for an operator, right? Specifically, a binary infix operator, right? How are we going to do this? So I think we look ahead during a type annotation the same way. So let's look how we get our type. See this? This is close. That's not quite. So not an equals, but a declaration means that we have a type. Here it is. Somewhere in here. Okay. So we advance the lexer and make sure it works. That's all that. Then we just get the symbol at the current token. So the lexer produces a new span within the source code. We get the span within that source code into a symbol. And then we get, using that symbol, the value. Okay, I think I'm just gonna steal all this. Well, no, we'll write it from scratch. We'll write it from scratch. And the idea, we also kind of have to undo it if there isn't one, which is gonna suck, but it's fine. So we may want to copy the current token, right? I think that may be the thing to do. And then we'll say, if it works, hey, I don't even know what I just pressed. I am in, okay. I alt-tabbed again on accident. I'm doing that a lot this morning. Alrighty, so if it works, update current token. I don't want to forget, so I'm going to write this to do for me. So we use the copy, and then we would like to advance using the copy, using the token length copy. So we'll just say length copy equals token length. And then we'll say char pointer end copy. So then we can just do something like this. All right, what's our error? It returns an error. If it does not equal error none, then just return that error, I think is all we gotta do. So that'll bubble it up. Bubble up the lex error. After lexing, create a symbol. So this is going to be operator symbol, sure, which equals node symbol from buffer. Just gonna put that on a new line to look cool. And the current copy beginning, and then this is going to be current copy end minus current copy. Well, we can use token length copy. That's right. That looks right. Now we need to allocate a node to write into. So we're just going to say operator value equals node allocate. And then we need to basically just get the parse context, look up the operator. So we're going to say parsing context global equals context. And then we're going to say while global parent global equals global parent. Look at us. So now we have the global context, and we would like to get from that environment of binary operators that we set within, we would like to get the symbol and write into the value. And then environment get has a failure, 0 for success, 1 for failure. So this will be int status or whatever. If status, yes, I'll do if status equals 0. This is a big problem. And we're going to say error generic could not. Well, I guess no, it's not a big problem. So if we don't get the operator, this symbol is not an operator. So all we have to do is say if status to do handle binary operator. Otherwise, just move on and it doesn't matter. And we need to free all of our things, like our operator value, and then we can free entirely our operator symbol. So this allocates, and they're both freed. Everything else should be fine. Alrighty, so now I guess the test would be math, right? Let's write some math. 3 plus 3. And then we have to pass it math. Hey look, we're nearly there. Int 3, none 3. Okay, so what happened? Printf here. Okay, so we do get here. So can we print node of the operator value? Can you tell me what that is? Hey, look. That looks like the plus operator. So we are getting the plus symbol bound to this operator. This is working, it's working. So when we get this operator, we're going to say our result, right, is going to be equal to, let's think about this. So this is actually where Pratt parsing comes into play. This is where the operator precedence will come into play. I think I've notes. Checking the paper notes. Yeah, here we go. Okay. So a few days ago, apparently, I wrote some notes. And sorry, this is probably awful sounding, but it'll just be temporary. I now have notes in front of me on how Pratt parsing works. So beginning, we look for a null denotation. We already did that. Upon finding null denotation, look ahead for left denotation. That's what this is. And then I don't think I need the status separately. I'm just going to do this. I think that's a little clearer what I'm meaning in the code as well. So upon finding a null denotation, look ahead for left denotation. That's exactly what this is. Every time we parsed an expression, we got here. So then every time we parse an expression, we look ahead. Is there some more? Upon finding left denotation, which is exactly where we are right here, parse right-hand side if binary operator. Okay, so that's a terrible note, but it means if it's a binary operator, a valid binary operator, and if the left denotation is a binary operator, because there may be other left denotations, then parse the right-hand side. But we do it differently based on what happens. So okay, so we're going to need like a precedence, a working precedence, and we may need a precedence stack even. if that makes sense. Oh boy. Lots of parsing. So the way we have this working result, we're also going to have working precedence. And it's going to start at 0 every time we parse. Do we have to pass this through? Should it be in the context? Wonder if we could just use the context. Interesting. Sobrepute says, hey man, I need to go. It's almost 12 a.m. here. That is all good. Thank you so much for watching. Sobrepute says, have fun with your stream and your compiler. I definitely will. I'll do my best. We're going to get this Pratt parsing done. And the VOD will be on YouTube. So, awesome. That's exactly what he said. He says, I'll catch up the rest of the stream on YouTube. Night, man. Good night. Sleep well. Thank you for coming out. Alrighty. What a polite Malaysian. They're all polite. Most people are in life. It's just the media that lies to you and says, hey, these people are different. And you're like, I just talk to people and they're like all the same. Everyone just kind of wants the same thing, just wants to chill and hang out. Like, I don't know. Eternal Wild Fox says, hello, Lenzer. Hello. Oops. How's it going, Eternal Wild Fox? Oh, you said hello, but I missed your message. My bad. I'm sorry earlier. I've been so focused. Sobrepute also followed. I feel bad I didn't mention that before he left. But thank you, Sobrepute, for the follow. I very much appreciate that. And we are one step closer to be those custom emotes and those channel points and those cheers and those subscriptions. Love it. I love it. Eternal Wild Fox says, doing well. What about you? I'm doing pretty good. This morning I woke up. I'm energetic. I don't know. Eternal Wild Fox says, I have the AST working. That's awesome. He's been working on a math expression engine, and he just got done this morning, parentheses, and operator precedence and everything like that. And now he says, I have the AST working. Not yet executing. That's okay. Just getting parsing something into an AST is hard enough. Evaluation is a whole other ballgame. We'll get there, right? So look ahead for things. If we get things, do the things. So I would like to get the operator precedence. So I'll just call this precedence. And it's going to be the operator value. And is it going to be children? So we have this value. So it is just going to be children, the integer precedence. So then children value.integer, like that. Eternal Wild Fox says, I am thinking how to evaluate it. Yeah, so what I recommend is kind of drawing it out, like the AST that you do have, like draw it out in either on paper or something like that. Or how to calculate, right. But basically the idea is you have a top node, right? I hate that this does that in the scratch buffer. But you have a top node and it has like a left and a right. And then it's going to have something on that, right? So the idea for how to evaluate is you start with the top node. And then you go, okay, it has two children, a left-hand side and a right-hand side. And if the children need evaluated, you need to do that first, right? Because you can't plus, multiply, and 4. You need to do the multiplication first. That's why the tree is structured this way. So the idea would be that what you need to do is first evaluate all children of a node. So you say plus, okay, it has the left child, let's evaluate that. Okay, that has a left child too. 2 evaluates to itself. It's a self-evaluating node. So then you, okay, save 2 in your like result. So this edge kind of gets 2, right? If that makes sense. And then with that result, you go evaluate the right side. And then you get the result of the right side, which may be more nodes. But you get the result of the right side. And then with the left side and the right side evaluated, you then just do the thing because you have the answer, right? And then once you do that, that becomes your new result of this left-hand side. So you see how you just basically, for each node, evaluate the left and the right. And that trickles down to get 2, 3, 2 times 3 because we evaluate the left, and then we evaluate the right, which is 4, and then we evaluate the top, which would be 6 plus 4, which is 10. Hopefully that helped. Hopefully I didn't just like talk at you for a few minutes and you're just like, this is nothing. I know this. Eternal Wild Fox says yes. Awesome. I'm glad. Sometimes these little trees, I need to go recursive. That's definitely the initial, yeah, that's definitely the first implementation. There are ways to get around recursion, but I don't think you need to think about it right now. So if you understand how to do it recursively, then just go for it. It's baller. Okie doke. So if precedence is less or equal to our working precedence, Eternal Wild Fox copy and paste some code in chat. What code is it? Is that PHP? Oh, the formatting. If it's PHP, we should be able to do something like this. Do I have PHP mode? I can't remember what it's called. Darn it. This is PHP, so, oh boy. Just trying to decode this a little bit. Okay, yeah. Yeah, this is making sense. There we go. Lamau. Yes, I know how to do recursion. Awesome. Most people know how recursion works, but being able to actually apply it to this situation is pretty impressive, right? That's why I didn't want to just assume you know how to do it. Because actually figuring out, like, wait, how does recursion work in this case? But if you understand how it applies to this complex problem, then that's pretty sweet. You've got it. If is set left and binary left instance of binary node. So that's like type checking on dynamic. I don't know what that means, but it's fine. And if is set. So if it has a left child and the child is a binary node, Eternal Wild Fox says yes, type checking. Nice. Then this pre-ordered, so some internal state to something, and we call, oh, that's the recursive call. Then we do left level +1. Nice. Yeah, and you even keep track of your recursion level. Very, very impressive. Left can be a number object or binary node. I see. That's why it's instance, I believe, right? That's cool, though. That's very cool. PHP has such an interesting syntax. It's almost like C, and it's almost like Python, and it's almost like Perl, and it's almost like Bash. It's like it's got all these things built into it. It's so cool. Precedence is less than or equal to working precedence. So if precedence, our current operator precedence, is less than or equal to our working precedence, then we're going to want to do a node swap, right? So we're going to say that our working result should be copied into a new node. So how do we do that? Do I have node copy? So I'm going to node allocate a node. Again, I should just make this able to be null, but not there yet. And this is going to be result copy. Did you see my last screen on Discord? I'll check it out. That button. Nice, I did not. Ooh, spicy. Yeah, very spicy. That's awesome. 7 plus 3 times parenthesize 10 over parenthesize 12 over parenthesize 3 plus 1 close parentheses, minus 1, close, over 2 plus 3 in parentheses, minus 5, minus 3 plus 8 in parentheses. That's pretty impressive. So that should be 10 plus 3 minus 1, 2, 10 over 2. That should be 5, right? 4 minus 1 is 3, 12 over 3 is 4, 10 over 4, that should be 2, I guess. So that should be 6. Okay, so we have 6 over 6 minus 5 minus 3. So we have 1 plus 8. Yeah, that's 0. I get it now. So 10 plus, yeah. That makes a lot of sense. The total answer should be 10. Yep, that makes a lot of sense. Because you're dividing by 1, and this becomes... Okay, very cool. Yes, it is extremely satisfying. I see what you're saying. Getting those bugs out. Like, finally. So we apparently... I would just like to make sure that this works. Hey, first time chat from a new viewer, Macon8. How's it going, Macon8? He says hi. Eternal Wild Fox says, hello, Macon8, welcome. Macon8 with the immediate follow. Thank you so much, Macon8. I very much appreciate that. Interesting. We're here. That's right, but our precedence, we're starting with 0 working precedence. So then we have to say the opposite of that. Good. So this should be, as we know, 12. But a naive parser would create $18. So it should be 12, and we don't want 18. Perfect, we still just get none. So the idea would be that our working result then becomes a new node. And this node will be a binary operator. Macronate says, I love your VOD of the compiler. And he says, good and you. Awesome. I'm glad you're doing good, Macronate. That's good to see. And I'm glad you love you're being entertained. You enjoy the content. I'm so glad. And I'm glad you decided to tune in. Thank you, Macronate. Mr. Mugame says, in the crafting interpreters book, all the tree traversing is done using the visitor pattern, and it makes the code really clean. Nice. That's a good pattern. I feel like that is part of what makes it so complicated, though, that book. It's like, can't we just do things simply first and then upgrade them to like some complex algorithms? Because sometimes recursion just gets things done fast. And you just should use like recursion everywhere and then go through and go, oh, I guess I could replace this with a visitor pattern or continuations or a different design pattern, right? I don't know. That may just be me. So in any case, we probably want this to happen. Maconate says, I am a C noob and I learned so much of your compiler building. I'm glad you're learning. That's a great result of these little streams I do that people get to learn. Sorry for my bad English. I didn't even notice you had bad English. And in here, but don't worry about it. We welcome everybody. Bad English is not a a deal breaker around here. We all speak bad English. Most of my audience is from Europe and not from America, so don't worry about it. People get you. And we're all here for you either way. Even if we don't understand you, we're still here for you. Still our friend. So then I think that the working result should get the result copy as a child. Right? Let's just comment these out for now. And let's think about if precedence is greater, then we just have to parse into the right-hand side. So we have to set working result equal to a new node. Is this how I do this? How do I do this? Something like this. So working result is equal to a new node. Yes. So we create the child. We update the result to that new child, and then continue. So we create the child. We update result to the new child. That's kind of what we did here, all in one step. And then what did we do? Then we set the child. So the idea would be that this can't just be node allocate. This has to be node pointer right-hand side. And added to the binary node. Okay, that makes more sense to me. Macronate says, okay, awesome. But yeah, never worry about it. We are all good here on our English. We don't need it perfect. In any case, we are now doing a little bit of parsing. So we get the right-hand side, we allocate a node for it, we add it to the working result. So if this doesn't happen, this is going to break things. So what is the case in which... So this operator... So we have some result. No matter what, we have to copy the result to the left-hand side. Am I wrong? I think I'm mistaken. I think I'm mistaken. Because sometimes I just have to parse into the right-hand side, which means I have to copy the current. Okay. The null denotation, upon parsing a binary operator, goes into the left-hand side. So there should be like an else. So in this case, we're still going to kind of have the same exact thing. Does this just happen no matter what? Let me think about this. I know I'm getting something wrong here. Just let me be dumb for a second so I can figure this out. So the result copy goes to the left-hand side of the child. The left-hand side of the binary operator. So this should build, upon seeing like 2 plus, we build plus with a 2. Macronate says, hello to Eternal Wild Fox, because he said hello earlier. We are all welcome. We are all present. Okay, so 2 plus. We want it to be 3, right? But if we get... So we just want to parse into the right-hand side by default. Copy our result that we got into the left-hand side of this thing. And then parse this. And that's what this does. This parses into the right-hand side of the variable declaration. That's all that does. But the problem is if we have... So let's make this a little different. Yeah, why not? 2 times... And we get times, times and 2. Then we've got 2 times 3. But then we're going to look ahead again. So while we're So while we're parsing the right-hand side, if we run into another one of these, right? So then we're going to have times 2, oh boy, 3. But then that's truthfully going to be a multiply with a 2, and it'll be replaced right here with a plus, which is kind of, yeah, it's fine. I think this should be fine. And then this plus, see, this is backwards. This is opposite of what we need to happen. Maddie Learns, first time chat from a new viewer. How's it going, Maddie Learns? You want to look ahead and repeatedly make a stack. That's what I was worried about, that we'd need a precedence stack. I was trying to avoid that because I don't want to write a whole linked list and API for that, but we're going to need it. I'm getting there, Maddie Learns. I appreciate that you assume you know what's going on right away, but we're working on it. So 2 times parse into this, 2 times 3, we get that, but then 3 looks ahead here once again and finds an operator with less precedence, in which case we need to basically flip it upside down. So our working result, is this our working result? No, our working result would be here. So we need to change our result and put it above. Yeah. Maddie Learn says, I might be assuming too much. Sorry, lol. It's all good. You're a new viewer. I don't expect you to know everything. I'm glad you decided to chat. No need to feel sorry. It is okay. How are you doing? We're working on some operator precedence parsing. This is the invalid tree and wouldn't make any sense because, but this is what it would build. So if we have 2 times 3 plus 1, why not? This would create 8, whereas the tree we actually need to create has the plus on top, and on the left has the multiplication. Put that one over. And then 3 and 1. So this is our proper tree, and this is our improper tree. So as you can see, even though when we get this node and we look ahead to an operator that has less precedence, right? If precedence is less than or equal to our working precedence. Again, have to use the stack most likely, but we're getting there. So our working precedence, what if we just replaced our result node with this? Okay. So we have to copy our result node kind of no matter what, right? I'm just going to do it either way. We're going to call this the else for now. And call that good. So the idea would be that our result is updated. So instead of our working result, which is our single number we just parsed, we would like to copy our entire result, which is this thing here. Well, it's this thing here because we just parsed into here. So it's this thing here is our result copy. Did I just do that in the wrong spot? I did. It's fine. It's our result copy. Give me a little bit of space so I can tell where I'm working. Not make that same mistake again. So we copy this node, and then we would like to set our result to a new node, add a child to it, which is the result copy. So now this has been flipped upside down, basically. This becomes our little binary operator. Ooh, I love hitting buttons and not knowing what it does. It's always scary. We copy result, so this should be in our result copy. We set result to our new binary operator plus, and then we add to the left-hand side the copied result from before, which should create that tree. And then we just have to parse into the right-hand side, and I think that's what that does, so run it and find out. It didn't work at all. That's wonderful. Let's figure out why. Let's figure out why. So we copy working result, we update it to a new node. So when we update working result, how is this node? This is just a new node. So our working result would be our right-hand side. Interesting, interesting. Okie dokie, okie dokie. So currently we have 2, 3, 1 with nones in between, which is interesting. So we would like to make sure that we're getting something. So I'm going to say got op bleh, and I'm just gonna do that. Got operator node with precedence bleh. Why not? So we're going to print out the precedence, and what is our operator? Operator symbol. Not sure what just happened. There we go. That makes more sense. Value.symbol. And we're just going to get some printouts, hopefully. Got operator star with precedence 10. Got operator plus with precedence 5. Well, that's a good sign. So the issue is that even though I update result, I figured out the bug. It's not really a bug, it's just me being not smart. Result is actually passed as an argument, so we cannot just allocate it like this. We have to kind of change it in place, which is annoying. So we have the copied result. So then result should equal like node none. You know what I mean? We should... Maddie learned says no debugger. No debugger. We don't really do debugging around here. We do sometimes if we have some big issues, but most of the time we run no debugger. Just wall, w extra, and GCC, baby. That's all you need. So this result equals node allocate is the problem. So result is currently this thing, and we have to change it into a binary operator like this, like this. So do I just have to do that? And instead of making a new node, I just do it in place? Not quite. Okie dokie. So now, Maddie Learn says, I love debuggers. Listen, they're useful. I'm not saying they're not useful and that I don't use them. I'm just saying that's not really how I write code. That's not how I develop. I don't need a debugger to tell me what the value of a variable is if I can just print it out and see it while the program is running, right? It's kind of confusing to me what the difference is. Like, I'd rather just write this one line rather than have to deal with like how a debugger works. Because I can use GDB, it's just not that much fun to use for me. I get my eyes glaze over and I stop focusing. So I copy the result. Can I just check if I'm ever here, I guess? Yeah, that's what I presumed. I was never here. So I would like to print up working precedence. And I think I know the issue now. I know the issue before I even do it. Is working precedence is set to 0. I guarantee it. That's our issue. We're initializing it where we shouldn't be. Look at us. We are. Every time. Every time. GDB is that weird, fully text-based debugger. You say you love debuggers, you don't know about GDB? Get out of here. It's the GNU debugger. It's not text-based necessarily. It's just terminal. You're saying that you need a graphical program to help you program? So working precedence should not change when we continue, right? Oh, maybe that's our issue. Are we not continuing? Oh, we're not. That would definitely be an issue. Ah, it's much better. It's not working, but it's much better. Maddie Learns says yes. Lamau. I guess so. If that's your style, you can do it. Mr. Mugame, Scratch has the best debugger, no cap. I would disagree. I think GDB is the best debugger. I don't think there is a better one. You can literally see like the disassembly of the current code you're running. You can see the values of every single CPU register. You can see, and it's like, it's only accessible if you need it. It doesn't just throw it in your face. You just type registers and then you see all the registers. GDB is pretty nice. It's like a REPL, but for your program. Your compiled program. So with a working precedence of 0, how does that happen? Because don't we set working precedence here? Precedence isn't 0. Precedence is 10. Then working precedence is 0. So this first time that makes sense, but this time we should get a precedence of 10, and we're not. I mean, we set it to 0 only in the loop, so doing a continue, or outside of the loop, so doing a continue won't set that value again. This is odd. This is odd. Because we're not calling parse expression, we're doing a continuation. So excuse me, why do you be like this? So we parse into the right-hand side, and upon doing that, our result needs to have our working result put on the right-hand side. Which I guess it already did. That's kind of how that works. So all I have to do is, yeah, right into the right-hand side. And yeah. So our issue is just working result, or working precedence, not updating. We'll do it here, at the beginning. Just gonna steal you. Go to the beginning of this loop. Tell me working precedence every time, master, every time. So if you lex, let me know that precedence, baby. Interesting. Working precedence gets back to 0. Maddie Learns says, you can do all that with Visual Studio Debugger and don't got to type nothing. But that's the issue. They just throw it all in your face. It's like, here's all the information ever. Good luck knowing what you need. You know what I mean? It's like, GDB allows for much more targeted debugging. Like, ooh, I think it's in this area, and then you go there. And I understand Visual Studio is a debugger, same as GDB. They can both be used. I'm just saying that you need a graphical program to write any program is kind of funny to me. It's like, at most, you should need a text editor. Before we used punch cards, programmers used punch cards for a long time. You know what I mean? So there's literally no recursive calls. We do it in parse program, but we never call parse program. So, why? So why? Because you would think that we're setting the result to binary operators, it would affect things, right? But it's not affecting things, which is quite interesting to me. And I think it would be quite interesting if we can get an operator with precedence, and then we print out working precedence at the top of the loop. MaduLearn says, I didn't say you need to, I'm just saying I'd rather click on a variable with my mouse to view it than type out the name. I see. That's fair. That's a fair preference. Absolutely. MaduLearn says it's a preference. Absolutely. We used the same word at the same time. That was pretty baller. Okay, so the idea would be y is precedence 0. See, this might be the case for a debugger. Get out a debugger and say, hey, what's this variable? When's it being set? Because you would think, whoops, that since we never call it, it would never be reset. And we only do this if we get an operator or whatever. Interesting. Because we never say got operator with precedence 0, but working precedence ends up at 0 once again. Shouldn't this just be a singular variable that never gets screwed with? It's kind of interesting, right? So maybe we're returning an expression when we shouldn't. That would be like a return OK being where it shouldn't be in this parser. I don't see a return OK. There's a break for this while loop, or this forever loop, excuse me. So no there. These are all return error or continue. Continue. Return or continue. Yeah, see, I'm not seeing why we wouldn't make it back here right away. It looks like we're parsing a binary operation and then giving up, which is very interesting to me. So working result, we're gonna have to do the same type of in-place thing here, I think. Well, working result we can change, but I think, yeah, working result is just changing from, so we copy the number we parsed into a new node. And then we say, okay, make a new node and add the number you parsed as the left-hand side. Whereas this says, use the result as that left-hand side copy. So maybe we have to write into working result because we've already allocated it in the previous continuation. So we copy working result, then overwrite it. That's valid. Hey, look, we're closer. We are closer. We get int 1 at the end. So we're not parsing the right-hand side properly. We should, because we're at the global scope. Context parent will not exist, so we should just pop out. In any case, let's figure this out. So we currently, control flow wise, we get an operator with precedence 10, and it replaces the current working result, our null denotation. That would be here, right? Because precedence 10 is not less than or equal to 0. So we'll say our result copy equals 2, right? That's what these two lines would say. And then this says our working result is a binary operator with a left-hand side. And then, after adding that child, we set the right-hand side. I'm going to get rid of these comments for now. So then we set the right-hand side to a new node, which is this none node. We add it. Yep, set the right-hand side. And then we update the working result to write into this node. Because node add child, new child pointer is used verbatim. So right-hand side should be the pointer directly to this right here. But then when we continue, that should take us up to not that while, but this while. And then we should lex again. And then we should get a token, right? And if it's an integer, we'll fall through. We'll look ahead again. We'll continue if we need to. But if we don't need to continue, then we will most likely break. So what happens where we return before we should, right? Because why doesn't this binary operator have 3 on the right side? And also, what is the binary operator? We're not keeping track of which one it is, which is probably an issue. We need to add a symbol somewhere. So hey, the symbol, you're going to be in use. You're going to be in use when we create the binary operator. We need to also say working result value.symbol. How's that? Then we don't actually need to free it. Well, we do need to free it there, but we still just need to free the actual, these two, the shells that we have allocated. Okay. And then when we print a binary operator, I would like to print the node value symbol. Look at us, that's much better. So now we can see what symbol we are parsing. So with this symbol, okay, oh boy, oh boy. Oh boy. So the idea should work, it just doesn't yet. It's a classic, right? It's a classic. The precedence blah, working blah. So we still get working 0 because we're not actually doing a continuation. We're just getting separate things. Which is kind of confusing because this should do a continuation. Ah! What if it's not? So basically we just need to update. See, remember we used the copies, but then we never actually updated anything. So we need to do all these backwards. So token length needs to equal the length copy. Because we need to say, hey, this is actually an operator and we parsed it. Ah. Hey, haha, look at us. We're doing it. It's done. Where are we printing node? Can I get a pog in the chat? That's pretty pog. So now our program, our math program, 2 times 3 plus 1, which would naively be parsed as the result of it being what? It would be... See, this would be placed in the left-hand side. So the problem would be that the multiplication would be on top. Also, there's some error here. Don't worry about it. So the binary operator has too many children. and an integer has a child. It didn't work perfectly, but it did work. We're getting the actual proper order of things, where the plus is on top, but the plus should have this operator on its left-hand side, and it should have, yeah. See, the issue is that we need to set children versus adding a child. I'm fairly certain, because if there's already a child here in result, it's been copied and stuff. We don't want it. Equals null. So, hey, that's way better. That is way better, folks. Okay. So, and then I'm sure it's the same thing here. Okay, nearly. We're just missing the 1 now. Anybody know why? Alrighty. Pretty good, pretty good. So no matter what, we allocate a right-hand side. So how does this plus not have a right-hand side? Isn't that kind of confusing? Does that confuse anybody else? So I guess we would need to do a stack continuation. Do we actually need to? Maybe we should just store the precedence in the stack. This isn't a bad idea. So the idea is that we parse the left-hand side, which is going to be 2 and times. We're going to get this. We parse the right-hand side, and in parsing the right-hand side, we find this, which gets us here. And then we say, okay, so copy this whole thing into the left-hand side. But then continue. See, this is different. This is different for both sides. Gotta use my head a little better. Or is this literally all exactly the same code except for this pointer? We copy this pointer. We set this pointer's type to a binary operator. We set the symbol. Okay. New plan. This is going to be result pointer, I guess. I don't know what else to call this. And if precedence is less than or equal to working precedence, then it's going to be result. Otherwise, it's going to be working result. I think this is all the same semantics, is it not? Result copy, null, operator symbol value. It's just which one we're actually using. Pretty sure. Maconate says, I have a question. Is it a bad practice to write char pointer string equals what? Is that an upside down quote? How did you even write that? What is that? He typed this. I've honestly just never seen this character before. You're blowing my mind a little bit. What is it? The character is bleh. It's a double low 9 quotation mark. Okay. Okay. I've never seen this punctuation mark. I'm going to assume you just meant regular quotes. And he says, so at Maconate, what did you say? Is it okay to write our pointer string equals string? Okay, that's going to break that. I think you meant something like this. Is it okay to write that? Or should one always take arrays? It's definitely okay to write that. So let's go look at my McElnate, let's go look at the lexer at the top of this file. You can see that's literally how my lexer works. It's just strings of bytes. And then those are used with stir spin, stir pointer break, and stir c-spin. And that's my lexer. Like, that's it, right? So that's definitely okay. You don't need to take. Maconate says, yes, sorry, German keyboard. Don't be sorry. I love finding new characters that I've never seen. It just blows me away. Like, what is that? I can't believe I've never seen that before. How did you type that on a keyboard? But that's cool. German keyboards have like that upside down quote. That's pretty sweet. Hey, look, we did it. Chat. Is that looking right? I think that's looking right. That's looking fairly right to me, baby. Let's do some, so this won't work with parentheses. Parentheses require the stack because parentheses require resetting the precedence to 0. And you need to return to the old precedence once you're done parsing the parentheses. So parentheses require a stack. We don't have that yet. But we do have PEMDAS, effectively, right? We have some very basic order of operations with operator precedence now. And it's automatic, and we can just define binary operators with the types that they operate on and their precedence, and then we can just say, hey, we are all done. Maconate says, thanks for the answer, smiley face. Of course, Maconate. I love answering questions from the chat. It's so much fun to interact and understand that, like, this is live. We're all just talking together, hanging out. It's cool. So yeah, we can now just implement operators just like that. The only thing we have to do now is implement the basic code gen that will take these operators, and the ones that are built in, it will actually, you know, use them. And then the idea is to have users be able to define their own operators, in which case we're going to have to treat them as function calls. It's going to be different when the user defines their own, because these operators will actually have their assembly like hard-coded into the code gen, right? Whereas the user-defined ones will only use these operators. So it's basically going to be a function call with 2 arguments and type checking. But since we now have, let's test some more complicated math. Does anybody know what would fool a parser? Like, we want multiplication last, right? Down in the tree. So putting it more at the beginning. Eternal Wild Fox says, damn, I got it to work without recursion. Yeah, so did we. Eternal Wild Fox, we're on the same road. We're on the same path right now. It's pretty sweet. We just got parsing operator precedence without recursion. It's beautiful. It's beautiful. It's awesome that you were able to figure it out, though, because that was your plan when you went away. You were going to evaluate this tree, the style tree with recursion, right? But you did it without it. That's so cool. Eternal Wild Fox. That is exciting. I've been streaming over 1 hour and 40 minutes. I would just like to thank everybody so much for watching. Be sure to hit that follow button. We are 2 followers away from becoming Twitch affiliate. We will get channel points, we'll get VIP members, we'll get channel emotes, we'll get everything. We'll get so much. The world will open up for us, so be sure to hit that follow button if you are enjoying. I thank you so much. Maconate, you followed earlier. Sobrepute followed earlier. Thank you so much. And I'm going to take the time now to mention that I have a YouTube link down below, and that stores all my previous broadcasts on Twitch, so you can go and see the entire development of this program from scratch, from nothing. And then you can also check out the GitHub link down below where this code is hosted. You can actually go and make a pull request if you think I'm doing something really stupidly, right? Go for it. And then there's also one more thing that I would like to mention, then we'll get back into the coding. Be sure to check out that donate button down below. If you have the extra dollar, if you have the extra generosity in your heart, I would greatly appreciate any and all donations. If you leave a message, I will read it on stream. And if you leave your username, I'll attribute it to you and say how much you did and everything. We'll have a fun, grand old time. In that vein, I would like to thank SF for donating $13.37 and VMe for donating $10.80. Thank you so much for donating, and I appreciate those power watchers around here, right? Them's them VIPs. But thank you to everybody who's donated. Thank you to everybody who has followed. Thank you to everybody who is watching right now. I appreciate you so much, and I just like coding, and I'm glad that we can hang out while I do it. So thank you. Eternal Wildfox says, what I doing? I have a calc function on my binary class. Left calcs also the calc. What I have doing? I have a calc function on binary class. Left calls also the calc. Okay, yeah, I'm starting to get it. So calculating a node that is already a binary node will calculate its left side. Interesting. Indeed. That's very cool. So using member functions in like an internal state, you did it. That's cool. That's actually really cool. I've never thought about it that way. If operator plus left equals null, right equals null, if this left instance of binary node, left this left calc, else if this left instance of number, left equals this left number. Oh, nice. So yeah, that's literally exactly what it is. So you're saying if this is an instance of a node, a binary operator, calculate it first. Else, if it's a number, return the number. That's perfect. So you're kind of seeing how evaluating nodes and self-evaluating nodes play together, right? Like the number just evaluates to itself, just returns it. But some nodes, like binary nodes, have to be evaluated further. That's so cool. Great job. That's really clean code. It's not like what we're writing here. Oh, that's awesome. Thank you, Eternal Wildfox, for sharing. It's so cool to see your progress. But hey, we did it. Binary operators with precedence parsing. Ain't that fun? And there's no recursion. And it's just right here. Also, we're going to try and make it a little simpler. And first, what I'm going to do is copy this so that I don't screw things up. Then we're going to delete it. And whoops, this pointer is going to be the result pointer. I think that is just fine. Hey, look, I got scared for a second because I was like, uh-oh, that's more things, but I forgot we wrote more math. And it's perfect. It's literally perfect. Multiply 2 and 3 to get 6. Divide by 5 to get 1. And then add 1 to get 2. Look at us. And then if we what if we add divide by 5 there? Oh, that's perfect. Oh, that's so perfect. Now it's the plus of 2 times 3 divided by 5 plus 1 over 5. That's so good. This is so good. PEMDAS, baby. Operator precedence using continuations. Look at us. That's fun. So to do, just gonna place that. I don't know where this goes, honestly. I'm just gonna place it there. And I'm going to say a to-do. Handle parenthesized, handle grouped expressions through parentheses using precedence stack. Because every time you hit a grouped expression, all you do is basically treat it as a really high precedence, or a very high precedence, because it has to be evaluated first. And then all you do is say, okay, when we run into that, it's a high precedence, so then the right-hand side just gets put into the different place, if that makes sense. going to be a little confusing because we're going to have like parentheses within. There's not going to be parentheses in the AST, but we're going to deal with parentheses during parsing. Want to see the code? It is one file, Eternal Wild Fox asks. Absolutely. If you upload it to like the Discord, hey, we got a new follow. How's it going, King10PA? Thank you so much for the follow. We got that lurker follow. If VMe was here, he'd hit us with that premium lurk emote, but we're all poor and we do not have that premium lurk emote. So I just want to thank you, King10PA, for watching, and feel free to chat, ask any questions, say hi. We thank you for being a part of this awesome compiler club. And guess what? You were the second to last follower ever from me becoming Twitch affiliate. So the next follower, that person will be the reason I become Twitch affiliate, along with you 49 other glorious people that happened before. I'm still validating if it goes correctly with multiple statements. Nice. Feel free to validate it, check it out as much as you want, but if you want to share it, post it in the Discord, I'll check it out. I'll read it, I'll try and understand it. I love trying to understand code that I didn't write. It's like a little puzzle or a little challenge. Like, can you figure out what this word says? This is awesome though. We have basic math. Look at us. So, type checking, right? That's where we're at. Nothing's being code gen, I don't think. Yeah, we just moved 0 into racks. There's not much being code gen for these expressions yet. Which we could do, but I'd like to type check the program before we do that. So let's do that, right? We're going to need the context, we're going to need the program, and hopefully that's it. Copy that thing, and then change it a little bit. Perfect. Perfecto, perfecto. Looks like there's something in the Discord, but my phone went off, but my my computer doesn't have a message yet. Suspicion, suspicion. Alrighty. Let me just make sure I haven't missed anything. Nope, that was not today. Okay. We're all good. We can continue. So all we have to do is start writing a type checker. A, B, C, D, E, F, G, P, Q, R, S, T. Okay. Gotta love that I still don't know the alphabet. Nope, that's not what I wanted. That's good enough. Type check program returns an error. And it's going to need the parser. So we're going to say node pointer program, and we're going to say parsing context. We really don't need to call this parsing context. We should have just called it context because we pass it all over the compiler, but it's fine. We should have called it symbol table. Just gone with the normal, normal name. Okay, so we now would like to type check this program. Return error. Error equals okay. Error prep. Error to do. Type check program. Pretty good. And we should probably get like standard IO and standard def in here, because I'm sure we're gonna need them. Whoops. Okay, now I can just go to my CMake and update the sources list with the type checker. And look, it works. And then it errors out. It says, hey, you need to actually implement this, bud. Alrighty. Not too bad, not too bad. Let's do it. How do we type check this program? We basically just have to say that there's an expression. Right? And while this expression, type check the expression. I think that's not too insane. Alrighty, so now we have some expression. I think we can switch on the type and type check this way. So default, do nothing. But when we have, for example, a function call, we would like to ensure function call arguments of correct type. So also to do would probably be make sure the function is actually a function, but I think our parser does that. So ensure function call arguments are of correct type. So to do this, we're going to have to get function info from functions environment. Sure. And then loop over it. Let's just do it. So should I parser get to get any, what is it called? Parse? I don't even remember. I probably have to write that function because we want to look in all of the contexts. We'll say while context, if environment get within the context of the symbol, which we already have as our first child, and we would like to get into some node. It's just going to be kind of a temp node that we use in a lot of places. There shouldn't be an else. It shouldn't be possible. When we need like an unreachable. We're going to need environment. Hey, Lander XT, back again watching the stream. Who thought I was blind? What? Yeah. Yeah, do that. Back again watching the streamer who thought I was blind. Oh, that's right. When you sent the Braille characters, I was like, wait, are you blind? Are you actually typing with Braille? That's right. That's right. You just sent, if anyone doesn't know what I'm talking about, Lander XT is in the chat now. How's it going, Lander, by the way? I'm glad you could make it to the stream today. And you were the first one here. You were the first one here, I will say. Oh yeah, but he in another stream sent a Braille invisible character, and I was like, "What is this character? How'd you even type it in? Are you blind? Do you use Braille to type?" But he copy and pasted it from a Unicode blank type of thing. It was funny. It was fun. Okay, so ensure the function call arguments are of correct type. So once we get out of here, we should say, okay, we have value should contain our function info. Not quite, huh? I didn't finish down here, question mark? Yeah. How are you doing, Landar? I'm glad you made it once again. Okay, we have an infinite loop, it looks like. Landar XT, to do, get a brain. Lamau, you're correct. So this should just say context equals context parent while we are looking for the function. And then we print the node. When we're done with that, then we break. Ah, that's probably it. That was not it. It was not that we're not returning a value. It was, what is it? Oh, here. Just like that. That's better. Cannot open output file, permission denied. That means it was still open. Hey, look. Something happened. So we can still parse. That's a good sign. And we get to do not implemented type check program. So we don't actually have a function call in this program. We have it in example. I have to run this from somewhere else. There we go. And now let's take a look at that. So we get a function call with a symbol and everything. And it's at the top level, so we should definitely get to it. I'm going to say print here. I don't see here, which is interesting. So while expression, it equals the child of the program. So the program, it equals this child. Type check the expression. If error, return error. Okay, so if we're returning error from here, it would be a big deal, but we're not. We never do, so not a big deal. So we'll move on, move to function. We don't have function, we just break, but then we get to function call. Something should happen. Should get something happening, no? Why is this not being called? Include the proper things. This is the type checker. We use errors, environment. It's something. It's something. I don't know what it is, though. We'll try returning OK and see what happens there. Literally nothing. Wonderful. But yeah, just to do not implemented type check program, we never actually print out anything. So what is the type, if you don't mind me asking? How do we print the program again? That's not good. Landar XT said, just noticed you're at 49 followers. I know, right? It's so close. We're so close. It's like, it's endearing. We are literally 1 follower away from VIP members, channel points, etc. 1 follower. Which is fine. So why do we get the program here? That would imply that we're passing program. Oh, that's because we're passing program. Hey, look, that's much better. Perfect. So now the function call, foo, gets us this function. Perfect. We probably don't need the body here, but we can store that separately, but it doesn't matter for now. We basically just need this first list of things, right? And these types. Okay. So we would like to say values equal to value children. Or we could have like temp node. Sure, why not? We're gonna have value in temp node. It's not great, but it's what we got because we can't make things within case statements. So temp node equals, whoops, value children. So value children, children. While temp node and not numpy temp node. Well, it is going to be. So this refers to this child. So function children, children. So then while temp node equals next child. We're going to say temp node children next child is actually going to be the type symbol, right? So this type symbol, let's just print it out, right? Why not? Nothing else that we really need to do right now. Hey, look, 2 type symbols and they're both integer. It's working. Now, we simply have to loop over the iterator at the same time. I've been streaming over 2 hours at this point. Just want to say thank you to everybody for watching. Be sure to hit that follow button. The next person to do it will be the reason that I become Twitch affiliate. And we get channel points, VIP members, custom emotes, all that jazz. So I really recommend doing that. And also check out that donation button if you have a few extra dollars and don't feel too cold-hearted today. Thank you in general. We're just gonna have some generic names that we can use in a lot of places. I'm gonna say iterator equals, see we have the function call. So the, oh Christ, sorry. So the function call second child. So it's going to be value children. No, not value, expression children, that's the symbol. Next child, that's this none. And then children, that's the first one. So now we should say while iterator and temp node. If iterator, so if temp node, but not iterator. So I guess if temp node does not equal iterator, because these should both be null at the end of the list. And if they're not null at the end of the list, then that's an issue. So if temp node does not equal null, then say, what does that mean? Temp node is what? Value children, children. Value is our function. So function children, children. So if temp node does not equal null, temp node is equal to our parameter list. So if our parameter list in our function is not null, that means that we didn't pass enough arguments. Pass to function blah. And we have like the function name and value. So value children, we don't have the function name there, we have the expression children. value symbol. Not enough arguments passed to function blah. That's good enough for now, right? We'll say error prep. Well, error create, why not? Error type. It's not really an error type, it's an error arguments. And this is going to say not enough arguments passed to function. And then this message, we're just going to say function. So it's a little more understandable. Alrighty, so that's not enough arguments. Too many arguments. How do we handle that? If iterator does not equal null, then that means that our function call iterator, is that what this is? Iterator? Yeah, iterator refers to our function call, I believe. So our function call children, next child children. Yes, so int 20. So while iterator, if iterator still exists, that means there's too many. So it's the opposite of this. But too many arguments passed to function. So we can go test that in our example by passing too many arguments. Hey, look. That's not too bad. We are printing some things we shouldn't. Look at that. So we compile and then it says function, foo, error, invalid arguments, too many arguments passed to function. We're type checking. We are doing type checking. This is amazing. We've checked no types, but we are doing type checking. And if we pass not enough arguments passed to function. Look at us. It's working. So what if we add another argument? Foo gets a, which is an integer. Macklenate says, hey, he gives a smiley face and thumbs up. Yeah. And it works. We get all the way to the end. Whereas if we remove it, too many arguments, and if we add one, like x, then it's say not enough. Ooh, spicy. Beautiful. Beautiful stuff. Alrighty. So we're doing argument counting for function calls. And now for each one, we need to do type checking. So this is a type symbol. So we need to get effectively, we're going to have to type check the, we're going to go with recursion for now, okay? Don't at me. So we're going to say error. I can't do that. Oh, I can't do that. Okay, this is going to get a little messy. And then create. Pratt. Okay. So we just return error. And break for each one of these. Everything should be just hunky-dory and not have changed, but we can also free these bad boys before the end here. What happened there? So free the value, free the temp node, and free the iterator. Why are you mad? Implicitly declaring free. Oh, we don't have standard lib. You happy? Okay, so now when we call type check expression, we would like, whoops, context here, and we would like to type check the expression of, let's see, iterator, not, am I correct? But we're actually going to have to get the type of this expression, not type check this expression. I mean, we're also going to have to type check this expression, but what's the type it returns? I feel like we should return that from here. No? Something like that? And then say like return type equals none. Perfect. Why not? So we're going to have int type, which equals no type none by default. Why not? And then we would like to say, write into this type, please, the result of this type check expression. And what that's going to do is, let's see. We would like to set the type to the resulting type of the expression. Should this just be separate? Maybe this should be separate. Let's not try and include it like this. We're still going to need that, I think. Well, yeah, try it. Expression return type. So to figure out the return type of an expression, we're basically going to have to do a switch. And default, just return the actual expression type. There's going to be some cases in here. I wish returns weren't so bad. So for example, the return type of a function is going to be its child looked up in the context. So that's when we can do parse get type or whatever. From context, look up which ID. So we're going to do node pointer results. Why not? We'll just name it the same thing. So the ID is going to be the function return type, which is, I believe, its second child. Let's go look at that. We cannot. Nearly. There we go. So the function has one child, two child, and this is its return type symbol. So this return type symbol, we would then like to use as an environment get in what? Well, we already have the type symbol. Did I mess that up? I think I messed that up. Let's figure out what is returned. Apparently nothing. No, we never call expression return type. So in our current context, given our current expression, not our current expression, we would like to check our iterator and see what it returns, please. So what does iterator return? If it's a function, well, functions don't actually return anything, so it would just return function. A function call is going to have to look up, so we'll just continue the function call thing. Get the function. So now result contains function. Function node, perfect. So I don't think I need to do that. So with this function node, right, what do we do with? What do we do with? For a function call, it contains the return type. The return type of a function call is the return type of the function it evaluates to. No? So Is this still not being called? I feel like this should work. No? We'll see. Here. So we're here for 2 integers, right? So they'll just return expression type. So then when we're type checking here, we print out temp node child blah blah blah, which is iterator. We get 20 and 34. So these are the expressions we need the return types of. But the thing is, we actually just have a symbol declared to declare what this is. So temp node children is equal to, and then next child. Okay. So 20 should be an integer. 34 should be an integer. So now we just need to use this to get the actual type, right? So type would equal get the type using this symbol and what is result in parse get type? That's actually going to contain our type info. We're gonna do it. One more. There's better ways to do this, but don't at me. It's not my fault I can't allocate within a switch case. So now get into result. Yeah, that's not gonna work. I've realized. Sure. Okay, so now we have this symbol. We should have a type within result. Yep, we're getting there. So if our type does not equal our type, I'm pretty sure we have a type error. And this is going to say argument type does not match declared parameter type. Yeah, why not? And do the thing where you print out which function you're in. I'm just going to steal that. Alrighty, so get the type of this symbol, which is what? What is this parameter? Temp node children next child. Temp node refers to our list. Okay, print node is not needed anymore. Else, we'll printf just for now types match. Hey look, we're doing type checking on function call argument expressions. Hooray! Oh man, we did it. So now, expression return type. So this is kind of type inference, and this is type declaration. That's very cool that we kind of have both. It makes me want to do it a little differently, with type inference being possible. But I think that we'll be able to convert it as time goes on. Whew, we just got so much work done that it is boring. We just wrote like an entire type checker in just like that, very quickly. And I am now tired. of writing the type checker. And I just have to return something. What do I have to return? Probably result type, right? What is this? Expression return type. So getting the return type of an expression. Whoops. Looks good to me. I exited abnormally with code 2, which means we did not type check. Wonderful. Let's do a git commit, huh? Oh yeah, can I just talk about something that I screwed up on yesterday in the last video? I'm not smart, and I come from Lisp, and in talking about lambdas, I wrote them very stupidly like this. And I said, oh yeah, this is all we need for a function, completely forgetting that we need to declare the return type. So lambda syntax has actually changed a little bit. It's going to look like this with the return type, parameter list, and then body. And functions, they're no longer going to use defun. It's going to use the same assignment as other variables. So it'll just be a regular variable assigned to a function, like this. And it will equal a lambda. Like this is the identity lambda here, an integer identity lambda. If that makes sense. So, and then we plan to have a shorthand where you can just not have function equals, and you can just plop this right where that is. And that will also work. But that's just simple parsing techniques for little shorthands to make it easier for the actual user of the language. In any case, we are now fully type checking function calls. Ain't that fun? Landar XT says, what user? I guess me right now. I'm the only one that's written in this language, huh? But once we can call out to C libraries, I think it's going to expand a lot and people are going to want to write things. And I think I may also want to write like, I don't know how to do it, to be honest, but I would love to have like the ability to run external processes from within the language. But that's like, that's a little far ahead. In any case, this is working. This is working. We wrote an entire, what happened? We wrote an entire type checker in about 30 minutes. Amazing. There you go. Okay. So in main.c, we just have to make sure that, yep, we listen to it. There we go. Done. Type check. So now our compiler, overall, we load the program from the first argument. We parse it. We type check it. We code gen it. And then we get rid of it. And it's working. And it's working. This is insane. I've never actually gotten this far on a compiler that's sophisticated with like static type declarations and everything. But it's coming together. This is exciting. And I want to figure out how to code gen some plus and minuses. So when we code gen an entire program, we code gen a function, code gen expression. So in code gen expression, this is messy. Ooh boy, this is messy. So yep, an integer, we'll just move the integer into some allocated register into its result. So then, I guess we just have to do it, right? Case node type. So if we get a node type of a binary operator, then we're going to do another switch. Ain't that a bitch? Okay, so if we get a binary operator, we would like to, I guess we don't need to do a switch yet. We need to look it up in the environment. So look it up in the environment. Environment get, I guess I have to do the thing. While context parent, context equals context parent, because operators are currently defined at the top level. I should have like an operator get, but it's fine. We'll get there. While environment get, within what environment? Well, the binary operators environment. I would like to look for a symbol. And this symbol, I wish I could not do this, but I'm going to have to do it. This is memory leaked. That's a big issue. Second argument is memory leaked. Very unhappy. Okay, and this is going to come from the actual expression value symbol. And then we're going to have to into result. So into temp node. Why not? Put temp nodes everywhere, baby. So if error.type break, because there's nothing we do after this other than return error. And it's a little safer because we can now free temp node. Look at us. We're being good boys with our memory. So now temp node refers to what? I don't actually know. Why did I just write printf instead of a comment? That was crazy. I'm losing it. I'm definitely gonna have to stop streaming soon, just so I don't lose my fucking mind. Is the main goal. So we never printed that out. Because we're doing the different one. That makes sense. Give me math. There we go. Now we're getting it. Is this from? What is that from? Hopefully it's just from this. It is. So this is okay. Codegenning symbol blah. Codegenning symbol plus, which has a precedence of 5. We don't have to worry about precedence anymore. We just have to worry about return types. So, interesting. We now need to basically get the return type of the left-hand side, get the return type of the right-hand side, and then figure all that out. Right? No, this is CodeGen. I'm a little nutty. Okay. So now that we have the data for the operator, I would like to say, hey, what is that operator? So our operator is stored in temp node. And temp node has a child. So we actually need to switch on, we'll just do this. Can I do this? Can you do strings? I don't know if I've ever done this. What's your problem? Statement requires expression of integer type. Ah. Okay. So since we can't do it on the symbol, that's gonna suck. So it's gonna be a little different. It's gonna be if string compare that symbol, or that one, equals 0 with plus, else, not plus. We got plus. Look at us. Okay. So we're going to need a bunch of these, but this is fine for now. Should probably have binary operators have like an ID or some shit. In any case, we are cogenning the binary operator of plus, and we need to get the return type of the left-hand side and the right-hand side, do we not? I believe we do. So, did I not? So we're going to have to include the type checker. Are we not? Why did I think I need the type checker? Let me try and think out loud a little bit. So if we get a plus, we would like to emit an add instruction and set our whole result register and everything like that. So this add instruction needs a left-hand side and a right-hand side of an integer. So I need to first call those effectively, right? Yep, I basically have to do this part. So just code gen the expression of the left-hand side, and then it will contain its result register. That's right. So plus we can guarantee in this type checked program that we have two integer return types from here. So this will be an integer within a register. But what's our actual expression? I think this should be something else. So we need to cogen the expression child. So this will cogen left-hand side, right? Cogen right-hand side. Emit readdress instruction. Look at us. And it's basically going to be writing into code, add, and we would like to add two registers, but we don't know what they are. They're going to be the first child result register and the second child result register. But here's the thing, we have to get the name of that registered ID. What are we missing? We need base, so this requires R. Okay, so now add is a destructive statement, so we can use the right-hand side and set our result register to that. So the right-hand side of our expression result register, our binary operator, will be stored in this right here, which is this right here. Hey, look. Math. Hey, look. Terrible math. What is this? Add racks to racks. That's not ideal. That's not ideal. How did these get set to the same thing? Oh no. What happened? So, cogen expression, if it's an integer, it's here, yeah. I'm gonna move integer to the top. I don't know why I made that not at the top. But you can see an integer just moves the integer into the register, but it sets its result register to a newly allocated register. Michael Nate says he's covering his eyes. See no evil, Lamau. The see no evil emote. Is this cursed? Is it just bad code gen, or do you think it's just code gen is too complicated itself? Because I would understand both, because this is bad code, but it's also it's also complicated because we're dealing with assembly now. So we set our result register. What are the result registers, right? Can we just start printing that out? So result register left-hand side. Result register right-hand side. Well, let's do the name and the number, right? And this is going to be what? This is going to be expression children result register next child, and we're also going to need the register name. Maconate says, I don't know, I'm a C noob. We're all C noobs at heart. It's okay. Nobody truly knows this mystical language, right? Always type INT and not I. I see some errors here. So if you have any questions, Mekonate, feel free to ask them. We're currently taking that parse tree that we generate, this thing, and we're trying to generate assembly from it, right? So we're looping over it and trying to make sure that we generate assembly in the proper way. So the idea is we'd assembly like 2 times 3, 6 over 5, and then that whole thing, right? 1 over 5, so plus 0. But we're currently not quite there yet, because I think our register allocation is broken or something. So if base in use equals 0, we can return the descriptor, return -1. So we can never return -1. We would just exit and say could not allocate register. So while base equals base next register plus plus. That seems fine. While base, if register descriptor equals 0, base in use equals 0, return base next register descriptor minus minus. That makes sense. So if you pass in 0, it would happen right away. If you pass in 1, it'd do the first one. This is all looking pretty valid to me. So while base equals base next, register descriptor minus minus if it's less than or equal to 0. If register descriptor is less than or equal to 0, it should never be less than, but we're just we still just get racks every time. That's odd. So when we add a new register to this linked list, Maconate says how many years you work with C. Less than 1. I don't know. Truthfully, less than 1. When I was 12 or something, I would write calculators and little terminal programs, like little games, text-based adventure games. I would write those in code blocks, that IDE. So that's where I started. That's less than 10 years ago, but about 10 years ago. I didn't actually understand much of C or what a pointer was. I just could do some basic stuff, like print out and things like that. But about a year ago, I got really into programming some more. You can see it on my GitHub. You see 3,000 commits in the past year, but it only starts 8 months ago, 9 months ago. But that's when I got into programming so much and I just started. And I just learned a bunch. So I'd say serious programming, I've only been doing it 8 months to a year. But actually writing programs in C, it's probably been 10 years. 7, 8 years, something like that. Then we say register create name. Our name equals name. Makes a lot of sense. Jopi Dwala asks, which compiler is this? This is the fun compiler. I don't really have a plan. I just want to make a compiler, and it sounds fun, so that's what we're doing. And it's in C with no dependencies. Ain't that fun? So yeah, this is our own compiler. Jopi Dwala. Maconate says, okay, not bad. It's true. So it should add to the end. So let's try and like have a register print. Ooh. Jopi Dwala says, I tried writing one, gave up after Lexer, lol. That's common. It's a very large project, so if you don't keep working on it, it's not going to get done. You know what I mean? So how do I print this? Say it name. And then, am I able to print Boolean values? Is that a thing? It's not, is it? Yeah, invalid. We'll just do an integer. Can't forget the new line. So you can see that none of them are in use. Okay, so then we're going to take this and make print register. Something like that. Okie dokie. So now we can print out our registers. And what I would like to do is do that when we're having our little issues. None of them are ever in use. Chat, is that suspicious? We never use any registers, Lamau. RIP. Jopi Dwala says, also, compiler needs a lot of algorithms and implementation knowledge, which I did not have. It can. It definitely can. It requires like mapping one thing to another, and in C, that's like hell. So I agree that it can be rough on the algorithms part and implementation knowledge, as you say. But if you don't know, then it's a great time to learn, ain't it? Right? No better time than now. So ideally, we should see something in use for this. So when we allocate a register in an integer, they're never happening. Interesting. Interesting. So let's do a very simple expression. Huh. Rax never gets updated? What? So we print the registers, then say int done. We're just going to do this so we can see. We have nothing in use. Then we have rax in use, then int done. Rax is still in use. Then we have another integer, and it uses R10, right? R10, done. And they're both in use. So that's working. We're now in use and working. But then we get rax twice. Lamau. So it appears that print registers should now, yep, things are in use. But the actual result registers are not correct. So the expression is a binary operator, int. So the integer expression result register should be allocated. So maybe register allocate isn't returning the proper thing. I'm pretty sure it's returning a proper register descriptor. It would never not return a proper register descriptor. That's how it's built. Oh man, I've been streaming almost for 3 hours today. I want to shout out everybody who has watched. We are 1 follower away from becoming Twitch affiliate with channel points, custom channel emotes, VIP members, so much more. So please hit that follow button and we will succeed in that journey. In any sense, we should now think about freeing the left-hand side once we're done with this instruction. So then we can register free deallocate from R to the left-hand side. Yep, that works, but this doesn't. So we code gen next child. So next child should have its result register set. But it doesn't, is what it appears? Is that what's happening? So printf, see result register blah. Oh, unless I'm just being very dumb. But no, so register name. We have expression children, so first child. Then register name expression children next child. So these should definitely be different. And this is expression children next child result register. Oh, and those are different. Wait, so these numbers are different, but we're getting the same string from register name. So register name is to blame. What's your issue, dog? It's the same one as before, dog. Hey, look, we did it, dog. Hey, look. Look at this. We're actually generating assembly for 2 plus 2. Ain't that beautiful? Ain't that beautiful? It's so beautiful. Okie dokie. Can you hear my voice starting to go out? I've been streaming for too long. I'm gonna drink some water. Make sure to stay hydrated. Keep that throat wet. I want to see your throats and I want to make sure they're wet. You know what that gets me? That gets me excited. There's so much wrong with me. So we can move integer into register. And a binary operator can now add these things together. I think it's pretty clear what is happening there. Use right-hand side result register as our result since add is destructive. Emit 3 address instruction. I think that's pretty clear. Free, no longer used, left-hand side result register. Beautiful. So now let's try and do something more complicated. And I guess we have to go and implement all those now, huh? Ain't that fun? So if it's a multiply, well, we'll do subtraction. Does anybody remember how sub works? I think it works like this. I believe it works like this. I don't remember. Okay, now we're gonna have division and multiplication. This should definitely be in its own file, because this is very messy and we can handle a lot of in its own file, not that, in its own function, because all of this is the same for each binary operator, right? Not every single one's destructive, but all that's the same. So we're just gonna do that. Like this. Clean it up a little bit. Sub is also destructive. Does anyone know multiply? Oh man, I hate multiply, because we have to use racks, don't we? Okay, this sucks. So we're gonna have to do some like 3 instruction emitting for multiply and divide. But it's gonna be fine, and I wouldn't worry about it. So sub is destructive, if I remember correctly. Hey look, big errors. Assertion failed, cannot create AST symbol node from null buffer. Interesting. Hey look, somebody to ban. I always love banning people. Let's see. What do you want? We'll just give them, yeah, we'll give them a ban. How's that? No soliciting. Not allowed. So we're gonna wait on multiply and divide because we have to use racks. But for sub and add, we should be able to do something. 2 plus 2 minus 8 plus 6. Hey, look, so stuff happened. So this is 2 and 2. Then we move 8 into racks. Subtract our 10, because that's our result from before. So our result of 2 plus 2, 4. 4 minus 8. Is that what we wrote? It is. 4 minus 8. Perfect. Is this how that's written? And then racks is our answer. I see. I was like, is this backwards though? This may be backwards. Is the destination here? We need to look this up. x86 instructions. x86 64 assembly sub. Felix Cloutier had that one, right? Is it still up? Felix? I don't trust all these other ones. Felix? There it is. I trust this one. I found it. Okay, so subtract R64 from RM64. Subtract R64. Yes, from R/M64. Oh, okay. So yes, so subtract this number from this number and store it there. Is that what? What? Okay. Yeah. The second operand from the first operand and stores the result in the first. Okie dokie. So what that means is, yes, sub works like this. So R10 now contains our answer. Then we move 6 into R10. See, isn't that an issue? R10 contains our answer. I know why, though. I know why. Because we're deallocating the left-hand side, but we have to use the right-hand side. Since sub is destructive. Haha, I figured it out. So this is going to be next child. Did that change anything? Let's think about it. 2 plus 2. R10 is 4. 8 subtract from 4. So negative 4 is now in R10. We move 6 into racks. And then we add racks to racks. No. No, you don't. We have to set the result register correctly. I changed the comment, but not the code. I was like, This is what we just fixed. Much better. So 2 plus 2, R10 contains 4. Move 8 into racks. Subtract 8 from 4. We have negative 4 in R10. Move 6 into racks. And then add R10, which was what, negative 4, to 6. So we have 2 or something. And then return nothing. Return 0. So if we just, at the end here, so the idea with a function would be that the last expression within it would be copied to racks, right? That would be the idea with a function. How do we do that, though? The last expression within it gets copied into racks. So we just need to set result register, racks to result register of our last expression when we are codegenning for a function, first of all. So to do copy last expression result register to racks. That's where we actually need to return things from, or within, I should say. Okay, so now at the end of generating all of our expressions, not there, here, then we should say, instead of moving 0 into racks, let's move something into racks. Expression, result register, register name. What's the issue? Oh, we need R. I was like, it's a string. Okay. Hey, look, it broke spectacularly. What did I break? Something here. Oh, I think I know. It's probably, yeah. So in parser.h, parser.c, when we node allocate, we use calloc. So node result register should be 0. So this should just return racks. So before we do this, let's just print out what it is. Expression, result register. It doesn't work. Oh, expression is null I'm trying to dereference. Look at me. Look at me. So I would like to say last expression. Why not? Hey, look. Now we can use that. Yep. And did it work? Code.s? It did. Okay, we should say if it's not equal. So we should say, okay, name equals blah. If name does not equal racks in this case, move it into racks. Otherwise, just keep it. Everything's fine. What goes here? Name. Oh, this isn't that type of language. I was like, wait, what? That's better. No? Name should return percentage racks. Should it not? Does anybody know? So print the name out, please. Man, we are getting stuff done. You see, it's percentage racks. I guess we wrote here, so it's done. Oh, we're still in the, no, that should do it. It wasn't updating. No, it was. We still have this. Why is move racks into racks? Who says that? right? I would like to printf this. Move racks. God damn it. Oh, because I'm being dumb. Inversed conditionals. Hey, look, we did it. So now if the return value is stored in racks, we'll just use it. Compiler optimization. Hey, look, so now we can use as and generate an object file from our assembly. Shell command succeeded. Now we can use LD to generate an executable from our object file. Succeeded. And then we can just run. And it failed with code 10. Failed with code 10. I don't think that's right. 4 minus 8 should be -4, plus 6 should be 2. Right? Maybe I'm not using integer subtraction here. Maybe it's doing unsigned. Is there a way to do signed subtraction? Performs integer subtraction. So it evaluates the result for both signed and unsigned integer operand and sets the OF and CF flags to indicate overflow. Signed flag indicates the sign of the signed result. Oh, really? So it should work. Its default operation size is 32 bits, but we use the rex prefix using rs, like the r suffix, r prefix, geez. So it seems like this works on signed numbers. Let's just try something that doesn't go negative and see how much it breaks. We should return 4 from this program, right? We do. We failed with code 4. We're doing math. Chat. Wait, guy. Wait. Hold on. Hold up. we just generated math. We did it. 2 plus 2 plus 2. What does that equal? Tell me. 6. It works. It works. Oh, that's beautiful. So we don't have multiplication, but what if I did -2? I'm just curious. So does subtraction work? Oop, I did not do that right. It does not work. Why doesn't this work? So this returns 4 in racks. So confusingly enough, we have R10, which contains 4. Then we subtract from R10 2, which is racks. 4 minus 2. Then we move the result, R10, into racks. And that's our return value when we return from main. Why is this not 2? Are we doing sub wrong? This is when we need a debugger. GDB code.exe. I did this wrong. This might break. Hey yo, we'll see how it goes. Pretty sure I definitely did it wrong. Yeah, it's gonna break because it's not allowed to access outside the environment. So if I could just figure out which one of you is holding things up and end you. Hey, look, I did it. Task manager for the win. Should have done that, I think. Right? And then, let's see. Disassemble? No? What is it? I don't remember. It's like list or something. So list stack, no symbol table loaded. Use the file command. So we'd have to do symbol file. Is that what it is? Yep, symbol file on, what's our code.o? No debugging symbols. So our problem is that we didn't generate debug symbols with as. That makes sense. I don't think we really need them. Oh, again, I did the thing that crashes the thing. I'm good at that. I'm good at that. But chat, we are actually getting this program, and it's somewhat working. It just seems like maybe I have the idea wrong about the destination operand. So the second operand, the source, from the first, and stores the result in the first. Sub R10 rack should be R10 contains the result. But it don't? So what if I sub from R10 like an immediate 2? Again, I just pressed the wrong thing. God, I love having a million things open. Oop, what happened? As says operand type mismatch for sub. So you can't subtract an immediate. You can. You can only sub from racks an immediate. Interesting. Interesting. So I guess the idea would be, so subtracting from racks, maybe that's our issue. Maybe it's like having racks on the right side isn't allowed. You think they would mention that. I don't think that's the case. We should just be able to put any register with any register. It would add into the left-hand side. So let's say we move our 10 racks, right? So then if we did sub, oh Christ, racks immediate, again, wrong thing, gotta love it. Operand type mismatch for sub. So sub doesn't allow racks like that, even though it should. Eternal Wild Fox says, the solution failed. That's okay. Not every idea we have is a winner, right? The important part is that we continue trying. How'd it fail? What went wrong? If you know. Sometimes it's hard to even know what went wrong. Alrighty. Very cool. So now we are going to see if we can't do multiplication and then get out of here. So a multiplication has to use racks. You don't know? Unsigned multiply. Signed multiply. Okay, so... oh boy. This looks like what we need. 2 operand form here. Yeah, okay. So from the register, multiply by that number and store it in that register. So it's a destructive imul. So imul is like sub in that it's destructive into the left side. Does that work? I didn't know imul had this operand form. I thought multiply had to use racks, but that's only unsigned multiply. Signed multiply has some niceties, I guess. So it's not exactly working, but we are getting somewhere. Okay. Eternal Wild Fox says, hard to explain. I think I'm going to research visitor pattern, I guess. Nice. That's a good idea. I've honestly never looked that up. Let me just look up what the visitor pattern is. I'm sure it's not crazy. There's no pictures. These are not helpful pictures. What? I'm not sure if this is going to be helpful to you, to be honest. So the idea, expression printing visitor? Oh, hell nah. Okay, feel free to do this. Feel free to go down this road. I do not know how this works at all. It seems very confusing. Separates an algorithm from a structure by moving the hierarchy of methods into one object. I don't see how that's better. So basically, you turn your algorithm into an object itself. So then a visitor is an object that takes in your object you're operating on. Okay. Okay. It's somewhat understandable. It's somewhat understandable, but it is very confusing. I would not know how to write a program with the visitor pattern. At all. I would have no clue. Common Lisp. Do something with object and engine and other object symbol. Format T, blah, blah, blah. Make an instance with, yes. Traverse to print elements. So traverse function auto, oh Christ. This is a pretty complicated pattern, I would say. Eternal Wild Fox says, yeah, it feels like shit. I would agree with you, man. I'm not understanding anything about this. So this is confusing. I think it's very confusing. If you can understand that stuff, that's incredible. But for me, that would be like, whew, right over my head. I can't get that stuff done. I like what? I don't even know what it was trying to say. So you have an algorithm that you split into an object itself, but then you pass objects to that object to create more of this. Like, it's so confusing. That's very confusing. For me, evaluation is simpler to just like have a working result that you evaluate into, and you just keep updating that result. So 2, 3 racks, 1, add racks to our 10 racks. Hey, look, it worked. Shell command failed with code 3. That's not what it should be. So what happens if I make this like end? Can I use goto? I use jump, don't I? So multiply into racks, and then just show me that. Shell command failed with code 3. Interesting. Interesting. I don't know where the code 3 is coming from, because we should just jump here after setting racks. I guess maybe I have it the wrong way. The first operand is the destination, multiplied by the source. The destination operand is a general purpose register. Yeah. So is this, do I have this backwards in GNU or something? That would be embarrassing. So if I just remove end, let's recompile, get this from scratch. Hello. And what if I just swap these around? Because GNU, I know, maybe it's in a different order. Failed with code 3 still. So no, that's not the answer. Well, this would be adding 1 to R10. So whatever's in racks, because this was backwards. Yeah, I don't think it's backwards, otherwise that would have fixed it. Just doing some assembly. So Hey, first time chat from a viewer. How's it going, Freddy Gamer 666? Hola amigos, ¿cómo están? We are all doing well. We are having fun coding in some low-level assembly with our code generator. It's being a little confusing, but it's not a big deal. Because IML is truncated and stored in the destination operand. Okay. So the idea in 64-bit mode, 8-bit cannot be encoded to access the following byte registers if prefix used. So we can't access the high bits. I think that's fine. Freddy Gamer asks, you know Python? I do know Python, Freddy Gamer. Why do you ask? Hey, Freddy Gamer 666 with the follow. Thank you so much, Freddy. Guess what? You are my 50th follower. Everybody celebrate. Get that PogChamp in chat. Because guess what? We are now officially Twitch affiliates. It's going to take a sec for them to activate it. But we're actually Twitch affiliates. We have 50 followers. That means we're an affiliate. That's amazing. You guys will get channel points. You guys will get custom emotes. You guys will get everything. Isn't that incredible? Thank you, Freddy Gamer, for that follow. You are our last follow for becoming Twitch affiliate, which we required 50 followers for. Thank you so much, Freddy. Freddy Gamer says, you work in Python. I don't say I would work in Python, but I know Python and I've written in it. Makonate says, congratulations. Yeah. Makonate, thank you. Everybody watching, be sure to check out the Discord down below where you can get announcements every time I go live, and also just hang out and have fun. Chat, show us your progress on your programs, right? It's a lot of fun. I really recommend joining the Discord. It's in the About section. Also, you probably couldn't see any of that. Announcements every time I go live, chat. It's a lot of fun. We have so much fun. I really recommend joining the Discord. In any case, we are now Twitch affiliates. Look at that. Look at that. Here, let's go pop off about that. We have reached 50 followers and an average of over 3 viewers. We are now a Twitch affiliate. PogChamp. There's no PogChamp, but I'm going to PogChamp anyways. So it seems like we're getting a little confused with imul. Maybe it has to be imulk? Does it matter about imulk? It shouldn't, but it may. Nope, still failed with code 3. Interesting. Interesting. So R10 contains 3, which means Rax contains 2, which means this happened. Look, this isn't working. So we're moving 2 into Rax, and then we're adding 1 to it, and it's like this imul never even happened. What? I don't know what's going on there. So this program somehow returns 3. And that's something for us to figure out on another day. Ooh, can we actually, There's no main? Lamau. Hello? That's not a very helpful disassembly, is it? We gotta work on our exported symbols. Lamau. Ugh. Thank you, Makonate, for saying congratulations. We are officially Twitch affiliate. This is gonna be so great. We're going to have so much fun. And I just thank everybody so much for watching. I appreciate you so much. I will take this time and say, if you do have the extra money and are feeling extra generous, I would greatly appreciate any and all donations that come in. It's one of my only sources of income, so I greatly appreciate everything that comes in. And if you leave a message, I'll read it. And if you leave your name, I'll say your name. So do that, but I won't dox you or anything. I won't say your real name. Or your email or anything. That's I think it in that case. So to do is going to be division code gen. And then also fixing these, because I don't think they work right. But we did it. So today we wrote an entire type checker. This type checker did not exist at the beginning of today, and now it does, which is pretty dope. It only type checks function calls right now, right? But that's not a big deal, because very soon we will be type checking all sorts of things. Binary operators, we'll have what else do we have? Function calls will need type checked. Variable reassignments, right? Variable reassignments and declarations that have initializations. We're going to require those. So, yeah, be sure to check it out. Be sure to check it out. We will be working on that next. For now, we wrote a type checker. We wrote some code gen for our new binary expressions. And we actually are running programs that our compiler is writing for us. Sorry, excuse me. Isn't that so cool? So our compiler can generate this assembly, then we can just build it and run it with GNU as, and it works, is the crazy part. Shell command failed with code 3. Look at that. Isn't that beautiful? It's beautiful. It's not right. We're taking 2 and then adding 1 to it. So somehow this doesn't work, right? Whatever this is doesn't work, but it's fine. In any case, we've done it. I'd like to thank everybody so much for watching. Be sure to check out that YouTube, where I have all my previous broadcasts, including this one, will be going up there, right? So be sure to go check those out. Watch me code more of this compiler. We also have a suicidal AI series on there that we finished up. Mecha8 says, bye, thanks for the stream. Thank you for watching, Mecha8. I greatly appreciate you. Everybody who is here. And yeah, thank you so much, everybody. I thank you for watching, and I will see you next time when we work more on this code gen and type checking. Our compiler is growing. It's growing. No, but thank you, everybody, for watching. Check out the links down below. Check out the Discord, where we can all be friends. Check out the YouTube, where you can see my past broadcasts. Hit that donate button if you're feeling especially generous and want to maybe have your name shout out or a message read on stream. I thank you. There's nothing more I can do, so I will bow and say good night.